Okay, so that's the problem, right? Existing encryption protocols are no longer secure. These asymmetric algorithms like RSA, DSA, Diffie-Hellman, these can be cracked by Shor's algorithm. So what can we do about it? There are broadly kind of three families of solutions out there that we see. And the first is post-quantum cryptography, or PQC. With PQC, essentially what we're doing is we're replacing the old math problems, those math problems that I mentioned earlier, discrete log and integer factorization, that have served us well for decades, but need to be upgraded because now they're vulnerable. So PQC is updating those old math problems with new math problems. This is a purely classical technology, so there's nothing quantum per se about it, but these are new math problems that are posed to be resistant to attacks by supercomputers, classical computers, as well as quantum computers. NIST is the National Institute of Standards and Technology. Here in the US, they're responsible for standardizing these new algorithms, and we expect those standards to be released sometime this summer or later this year. Now, the second two families of solutions are QKD and advanced secure networking. And so these two technologies do actually rely on quantum signals and quantum physics for security. So it's kind of using quantum to protect from quantum attacks, right? So with QKD, the idea here is that we're using quantum physics and quantum signals to communicate between two nodes on a network to establish a shared symmetric cryptographic key. There are some pros and cons with this technology, which I'll dive into a little bit later when we compare them. And then advanced secure networking, really the core of this technology is that it relies on entanglement, quantum entanglement. And this entanglement can be used for a variety of crypto systems, which I'll get into in a bit. But both QKD and advanced secure networking do have this notion of theoretical security, that they will be, provably secure from attacks by, any computational resource. So if it's a big supercomputer or a big quantum computer, in theory, that these quantum-based protocols will maintain their level of security throughout time.